going to create a project. I want to create the game Hearts. I have this up just to show you what the game Hearts is. This isn't my game, and this isn't exactly what I want to create either, but basically the card game is what I'm talking about. I'd like to make it a web application, C# back end, Angular front end, networked, so multiple players can play, possibly some kind of ranking system, keeping scores, various other features, maybe chat, but just add those features as they go. So that's what I'd like to build. It's a pretty large project, even if I'm doing sort of these condensed 30-minute videos where I'm cutting out a lot of the debugging and troubleshooting time. At one per week, I expect this could easily take a year, possibly even 2 years. So it's an ambitious and long project. Anytime you're going to start a large project like this, anytime I'm going to start a large project like this, the first thing I want to do is slice off some piece of work to start with. And I always like to shoot for what the agile methodology espouses, to take off a vertical slice of work. So what they mean by that is don't start by doing just the back end and then moving on to just the infrastructure and then moving on to just the GUI for your entire game. Because what's going to end up happening, or what can happen a lot of times, is you'll spend a lot of time on the back end and then you'll get to the GUI and you'll realize that you did the back end all wrong because you hadn't thought about some very important factor about how they'll have to integrate together. Um, or the reason the Agile philosophy, specifically the Scrum philosophy, talks about it so much is it's very keen on doing regular demos as often as you can with the customer. Um, if you're working at a company, a big part of the reason behind this is that the customer usually doesn't know what they're doing. They don't know what they want. So they'll try and ask you for what they want, but they don't actually know. So if you do a lot of work on the back end and then you can't really demo any of that because it's just in the back end, not like anyone can see that game. So then you start to add a GUI and the customer says, oh, did I say hearts? I really meant something completely different. And now you've just wasted all that work you did on the back end. So Scrum is very big on continuously demoing to the customer as often as you can and doing tall vertical slices where each slice that you peel off has basically, it doesn't have to have work from every single layer in your application, but it should be a piece of functionality and not tied to a specific layer. So let's go ahead and jump to my notebook. Anytime I'm working on a personal project, I tend to use my notebook. I use Jira and Trello and all, Word documents, fancy tools for when I'm working professionally or working with other people on a project. But when I'm working with myself, I find that the maintenance of those tools tends to be more of a headache than it's worth. I keep a journal with tons of stuff in it, and so on my notebook, I can keep track of these things a little bit easier. So what I've done here is I've kind of sketched out my vertical slice that I want to tackle to start with. And what I want to do is, this is my web page here, show basically a shuffled deck and keep track of how many times it's been shuffled. So every time you refresh the page, times shuffled will go up and you'll get a new shuffled deck. And these are just lines of text. There's no fancy graphics or anything like that. One page, no URL routing. I jotted down a few notes about deployment. That's not terribly relevant. And just sketched kind of the architecture of what this would look like. So I have my bottommost layer, my domain layer down here, where I've got, my playing cards and shuffling goes on down here. My infrastructure layer, part of the reason I want to keep track of the number of times shuffled is so I have an excuse to put something in the database just so can get that all wired up and ready for me, because I'm anticipating I will need a database in later versions of the application. And then my GUI, it's an Angular application, so I've got my top level component here, playing card component here, which will just match each of these lines of text. So I'll take that playing card object, turn it into a string of text. And I jokingly called this week one architecture and week one expected output. which is ridiculous because it ended up being a lot more than 30 minutes of work. So what I'm going to focus on today is just this hearts domain. So I know I just gave this talk about vertical slices and doing work across all of the layers. This is my vertical slice, and now I'm going to do the actual work. And when you're doing the work, you can't work on all layers simultaneously. So I'm just going to work on this lowermost layer today. And as I work on this vertical slice in future episodes, I'll tackle the other layers. So let's go ahead and get started. Going to go ahead and create my application here. So I've done probably just about every version of repository to project mapping you can think of. I used to be a much bigger fan of having lots of small repositories, and now I've come to really enjoy having lots of small projects, but few repositories. So for this project, I'm going to try and do the whole thing, at least for now, in a single repository. Both the back end and the front end will be in this repository, and all of the various projects on the back end and the various projects on the front end will be in this one repository. So just going ahead and creating a project for the hearts domain and tests for it. This code is going to be pretty straightforward, plain old C# code. So I'm using Visual Studio Code here. It's not necessarily my favorite IDE for editing C#, but it's free and I use it for TypeScript and Angular. So since I'm already running it most of the time, I tend to enjoy it. One of the things I don't like is I don't have a very good integration with any kind of static analysis, so that'll come up here in a minute. I'm pretty bad at remembering to include the namespace, and then I end up with a bunch of classes in the global namespace, and then I catch it later and I have to go fix it. So I think I'm just about to make that mistake here on this S1E1 actually, but I'll come back and fix it later. So this playing card class that I'm creating is pretty basic. It's just got two fields, rank and suit. I've embarked on creating a card game project more times than I care to admit. And a lot of times I didn't get very far. Sometimes I got really far and then I kind of gave up. As I've done it, it's a fairly complicated project, so every time I learn more and have some new confidence that I'll finally be able to finish it. Oh yeah, I was going to write an equals method here, and then I realized I don't really need it for the application. So I may not be all that keen on kind of the test first development in the sense of always writing your tests first. You'll notice here I'm writing the class first, but I'm pretty big on not doing work that you don't have to do. And I should mention, let me jump back up, I kind of skipped past this. When I sketched out this architecture, I didn't scan that page, but I also kind of thought about what tests I might need in this application. And so what you'll see is here I'm going to have a few tests just to make sure that I'm generating a deck properly, that I'm shuffling it properly with my database access and my infrastructure. I'm always going to need a few integration tests just to make sure I've got this plumbing wired up correctly. If I'm keeping track of how many times something is shuffled, I'm going to be incrementing something in a database. So there's always some threading concerns around that. So I'll probably have some kind of threading test around my data access. And up here in my GUI, there's not a lot of logic here. I'll probably have a unit test around my card component. And I'm going to have certainly some end-to-end tests just to make sure that I'm wiring everything up correctly all the way from the top to the bottom. So a lot of times you'll see that testing pyramid where people like to see a whole bunch of unit tests at the base of the pyramid, and then you have your integration test as a slightly smaller layer, and then end-to-end test is an even smaller layer, and then manual test is like the top of the pyramid, the smallest layer. Since I'm just starting, this application doesn't have a lot of logic. There's not very much in the domain layer here. We're not going to end up in this vertical slice with a bunch of unit tests. I wouldn't be surprised if we ended up with more integration tests and end-to-end tests than we have unit tests. And that's not necessarily a bad thing. You want to just kind of, one of the hardest things to do with testing is to make sure you get that right balance of tests. So that's what I'll be shooting for as I go through this. So I went ahead and chose to use a static method here to generate a new deck. I could have created a deck factory class. That would have been fine. There's a lot of different ways that you can tackle any kind of problem that you run into, and so no one way is better than any other. A lot of times, sometimes, you know, there are advantages to certain approaches. It's going to be a pretty fairly small method, so it also doesn't have any real dependencies, doesn't introduce any additional complexity, so I didn't see much disadvantage in making it a static method. And it's a fairly common pattern to have static methods on a class that do creation, if that creation tends to be more complicated than just assigning properties. And here I'm actually creating multiple instances of the playing card. So I'm just iterating through all the suits and all the ranks to generate one card of each. And again, I'm not doing a lot in that playing card. Here's where I forgot that namespace. Come back in and add it. You'll notice I just have rank as a number. I'm not worrying about the fact that a 12 is a queen and a 13 is a king. I will need that in my vertical slice by the time I'm done, but that's really a display concern. In the back-end logic, rank is more of a number. And I could get all tied in knots about, should the ace be rank 1 or should the ace be rank 13? I'm not going to worry about that right now. The ace is rank 1 when I'm doing this vertical slice. If that ends up not making sense when I do the hearts logic in the actual game, then I'll just change it. If I need it to like switch back and forth, then I'll wait until I actually need that. I think hearts, it's either high or low. I think high, I forget. But I'll look up the rules, but it's one or the other. So I'm not going to need that switching logic in this entire project. So that was one of the mistakes I used to make back when I got started. So here I'm creating the shuffler. I'm taking in the random number generator as a dependency. This will allow me to unit test it more easily. The shuffling method turned out to be quite interesting. I was used to Java, where there's a collections.shuffle method provided for you in the standard library. And I always knew it used the Fisher-Yates algorithm, but I never knew how that algorithm worked. And I just kind of assumed it was either a very complicated algorithm or explaining how it worked was very complicated. So I just Googled Fisher-Yates for C#, found this on Stack Overflow, put it in here, and I ended up revisiting this later to figure out how it actually works, and learned quite a bit. So I'll go over that algorithm in more detail. But for now, all we need to know is if you have a uniform random number generator, you can use that algorithm to shuffle a collection. And in this case, I'm using it to shuffle my cards. All right, so go ahead and start on my tests here. First, to test the playing card, there's really not much logic there. The only thing that's really in there, and I'm not going to test that the ranks get set or gotten properly. You don't need to test axis properties, and if your getters and setters are really straightforward, there's not much need in testing those. I am going to test that it generates a new deck correctly. This isn't the most complicated bit of logic, so I can't say I would always write a test like this. I forgot to add a reference to my actual project, so adding that in real quick. But it is pretty straightforward to test, and it's a pretty simple test. It's fast, it's stable, so it doesn't harm too much. So go ahead and create a new deck, and then I could have 52 different assert statements to make sure that every single card is in here. That would be overkill. I'm just going to check a few basic properties, facts that I know happen to be true of a newly generated deck of cards. So make sure that there's 52 cards in the deck, and I want to make sure that For every suit, I have 13 cards of that suit, and I want to make sure that for every rank, I have 4 cards of that rank. If all 3 of those things are true, then the odds of me generating an incorrect deck are pretty low. And like I said, the logic isn't that complicated, so I'm not too worried that I got it wrong. I'm using link here to count how many instances of each suit are in my deck. So say deck.where, that's going to filter down my list. So I have a newer, smaller list of only the cards that match that suit. There's actually a bug in this statement, so see if you can catch it. I'll catch it in a minute here. I'm adding a string description to the test case. I don't normally do that. Maybe I was just in a descriptive mood. It certainly doesn't hurt. It would be, if the test fails, more obvious what went wrong than just saying expected 12 to equal 13 or something along those lines. And with this test, again, I can think of the different ways that a playing card might change as time goes on, and would this test fail? So, a playing card might add new properties, equals or comparable. We could add, like I said, we could change some logic around about how we're dealing with the ace, which might change how we count each of the ranks. But in general, this test should be true as long as I'm dealing with a deck of playing cards. These 3 statements should always more or less hold. So that's one thing you can look for in your unit tests. When you're writing unit tests, you should be writing tests against kind of the logical concept and not necessarily the implementation. So here's that bug. It was expecting 13, but it got a list of cards. Using link here, I'm calling where to filter it down, but I actually want the count of cards matching that criteria. So go ahead and throw that on there. Back to kind of what I was saying about a logical concept. When you're writing, it's not so much when you're writing infrastructure and not so much when you're writing necessarily maybe a GUI, but when you're writing your domain layers or modeling something in the real world, which is what we tend to do in our domain a lot of the time, there are real world equivalences for the concepts that we're describing. And so you want to write your test around that real world thing. For example, a lot of times in the corporate world, we're going to be writing tests around corporate policies and business rules. And so we want to write our tests around those policies and rules and not necessarily actual code or implementations, which is all fairly esoteric. Went ahead and created a base test here that has a random number generator that's set to a fixed seed. So if any of my other tests in the future end up using random number generators, I don't have to do that again and again. And this is my shuffler test. So what I want to do here is basically test that shuffling algorithm I wrote and make sure it's working. And here I actually go a little bit astray. Not here right this moment, but in this test. Here I'm just, I don't know, I was doing something silly. Because my initial thought, anytime you're testing something random, it can be a little bit difficult how you would test that. And so my 2 very easy criteria for any kind of unit test, or the unit test should be, or really any kind of test, doesn't matter if it's a unit test or integration test or an end-to-end test, should always be fast. And that one's a little bit flexible. You can have a few slow tests here and there. Some people will put them in a different suite. But it should be fast and it should be stable. And that one I don't really tolerate any wiggle room on. Your test should reliably pass every single time. As soon as you have unstable tests, you lose confidence in your test suite. So that's one of the things that can be a little bit difficult with random number generators. But I looked at this And I said, okay, I have a fixed seed. So I shuffle my deck, and I'm putting some code in here. I thought console.writeline would work. It ends up not working. But I'm putting some code in here so I can just look at what are these cards, visually inspect it, and see if it's actually shuffling it correctly. And then for my test, what I end up doing is just saying, okay, I know if the seed is 42, the first card should be X and the second card should be Y. I forget what the actual values are, but something like 7 of spades and 11 of diamonds. And so then I just, in my unit test, write, it must be 7 of spades as the first card, it must be 11 of diamonds as the second card. This test is fast, and it is stable if I don't touch my implementation. But you have to kind of look at, why are you writing a test? And if I'm writing that test for the purpose of just making sure I wrote the shuffler correct, it's not necessarily a bad test. But when we write tests, we really want to guard against changes that we're going to make in the future. And so one thing that's always good to think about when you have a test is, what are ways that the class I'm testing could change in the future? And so I can think of a couple ways. How would this shuffler change in the future? And so one thing I might change is, maybe I decide that the system random number generator isn't good enough. Um, and so I want to use maybe a cryptographic random number generator. Now, I really don't, because that would be slow and there's no reason for that kind of security. But if I made that change, what would happen? Well, a cryptographic random number generator, I don't even think you can give it a fixed seed, but even if you could, it's not going to come up with the same two things that system.random is going to come up with in the shuffle. So this test would break, even though I changed my class in a completely valid way. Another way that I might change this class is, I may find, as I'm writing my code and running it and so on, that I'm not dealing with some corner case correctly. Maybe I'm not dealing with the case where I have a list of size 0, or maybe for really large lists, or maybe just certain values break that in some way. And so I have to go in and I have to fix that bug. Well, any bug I fix in those lines could very likely change the order in which I'm generating random numbers. And that would cause my test to break. So if I change the conditions on my for loop because I realize there's a bug or something like that, that would break my test. So this is telling me that this test is not a great test. Now, I didn't think it all the way through at the time that I was writing this. I thought, this is a good enough test that I can verify that this thing works, which sometimes that's not bad. But now you have to think too of, all right, so is my test better than no test at all? And um, when I'm testing this, that test is going to take time to run. And once I've verified it works, it's not really giving me any value. It's not guarding against any possible change I could make to that class. Any possible change I can make to that class is almost certain to break the test, which is going to cause inconvenience down the road. So that test is almost not better than any test at all. Luckily, I took this break here, and while I was taking a break, I decided I wanted to learn more about this shuffling algorithm, this Fisher-Yates algorithm. And it's a pretty interesting algorithm. So I'm going to go over it real quick. So what I have here is, I have a list of numbers, and I want to shuffle this list of numbers, just mix it around and get some kind of random permutation out of it. So the way Fisher-Yates works is, it has a pretty common sense real world analogy, which is, okay, let's take our numbers, let's throw them all in a hat, shuffle up, shake the hat and draw them out one at a time. And if you do that, you should have a randomly generated set of numbers. That should be a pretty good way of shuffling your numbers. And when you think about what's a good way, it turns out, as you're learning about the algorithm, they talk a lot about why it's such a good way, other than just the performance reasons, which is Fisher-Yates tends to be very fast. There's the fact that it tends to be uniform. So any combination of 6 numbers here should be equally likely. So I should have the exact same odds of ending up with 1, 2, 3, 4, 5, 6 as I do of ending up with 2, 3, 1, 4, 5, 6 as I do of ending up with 5, 3, 4, 2, 6, 1. All of those combinations should be equally likely. So a good shuffler will give me an equal chance of every single combination that I have here. And so let's talk about how this actually works in implementation. The way that Fisher-Yates works is, again, we have this analogy. We've thrown all our numbers into a hat. The first thing we're going to do is pick our first number out of the hat. And so to do that, we generate a random number between 0 and 5, because we're using zero base indices on our list here. So let's go ahead and 0 and 5, we get 2. So we grab the thing at list position 2, and we swap it with the last thing in the list. And this will seem a little strange to start with. But the nice thing, we've done that swap. The reason for that swap is now our list is broken into two pieces. On the right side, we have the numbers we've drawn. And on the left side, we have everything that's left in our hat. So now we generate a random number between 0 and 4 to pick our second number out of the hat. 1, so we'll pick this 2 out of our hat. And now, again, 2 and 3 are the numbers we've drawn, and everything to the left of it is what's left in our hat. So now we generate a random number between 0 and 3. Every time we go through, we're going to drop our max by 1 here. So 0, so we take the first item, and we swap it with the, I keep saying the last item in the hat. So now our hat is right here, so we generate between 0 and 2. 1. So now our hat is right here, so we generate between 0 and 1. 1. So we swap it with itself, which is fine. It stays in the same place. And now our hat just has one number in it. We don't need to generate a random number to know what we'll pull out. So now we have a shuffled list. 4, 6, 5, 1, 2, 3. And we got that by essentially drawing numbers from a hat. Now it turns to be fast because we just go through each item in the list, generate a random number. So if you have a list of size n, you generate n random numbers and do n swaps. And it's pretty fast. And an interesting thing I learned from learning this algorithm, I'm kind of happy I did because of this, is the problem often comes up when you have a large list of, let's say, 1,000 things, and you just want to pick 5 things out of that list without replacement. Well, you can use Fisher-Yates as long as you don't mind the fact that you're reordering your list, and just stop after you've picked 5 things. So random number, swap, 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 stop. You don't have to go through and shuffle the entire list of 1,000 items. It can be a very fast and efficient way of picking a few items out of a collection without replacement, in addition to being a good shuffling algorithm. And now if we actually look at the algorithm, it should make a lot more sense. You'll notice in the example and in my algorithm here, I'm starting at the end and working my way backward. You can also start at the beginning and work your way forward. Convention is to start at the end because some of the math works out a little bit easier. But basically, we're doing a loop here. Again, this is the thing I grabbed off Wikipedia, so I don't know why they're using a while loop. I probably use a for loop here. But we start at the end of our loop, cards.count, and while we're not at the last item, the very first one, which we just leave in place because there's nothing to swap it with, we pick a random number between 0 and the end of our wherever we currently are, and we do a swap. These 3 lines are just a swap. So that's all it is. Pick number, swap, move backward. Pick number, swap, move backward. And so now that I understood that, how it worked, I'm actually able to write a much more meaningful unit test. So I learned about the algorithm and I said, okay, well, the reason that Fisher-Yates is supposed to be so great is because it shuffles things uniformly. Every combination has an equal chance of occurring. So if I wrote it correctly, then every combination should have an equal chance of occurring. So I'm changing my test here. I'm not going to use the new deck anymore. I'm actually going to fix it to 3 specific cards, just so there's a smaller number of combinations. And some people might also argue that just by getting rid of the call to new deck, I'm making the unit test better because now it's depending on fewer things. And so it's less likely to break. And this is the whole idea of the very pure unit test. It should be testing only the class under test. I'm not a big believer in pure unit testing at all. I don't see any problem with using other classes within the same project or module. As long as your test is still fast and still reliable, I don't really see that being a problem. And as long as you're not, if you have a dependency on something that's in another project or another logical domain, then yeah, I could say that maybe that's not a great unit test. But if you've got a couple of classes in your domain and they're depending on each other in their unit tests, it's not necessarily a bad thing. So what I'm doing here, I've got these 3 cards just to get a much smaller list of combinations. And my 3 combinations that I could have now are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. And so I've got this method here, get combination number, which is basically going through and assigning a number to each of those combinations. So I take in a list of cards, and if it's 1, 2, I don't have to check it's 3 because that's all that's left. If it's 1, 2, 3, I call that combination 1. If it's 1, 3, 2, I call that combination 2. 2, 1, 3 is combination 3, and so on. Eventually, I end up with 6 combinations. And what I'm going to do in this test is I'm going to go through and run the shuffler a bunch of times. I think it ends up being 1,000 times. And I'm going to look at how many times do I get each of the combinations. Um, so I'm going to keep a big count of how many times I get each combination. And then at the end, I'm going to look, and if I did it right, there should be, it's not going to be perfect. If I ran it 600 times, I wouldn't expect to get 100 of each combination because there still is some randomness in it. But they should all be fairly close together, the counts. If I'm getting 10 of one and 400 of another, then I've done something wrong, drastically wrong. So I'm using a dictionary here to keep track of my counts. Anytime I use a dictionary, I tend to name my dictionaries key to value just because I'm not good at coming up with names, and so this saves me from having to do that. So this dictionary is going to keep track of mapping combination number, that 1, 2, 3, 4, 5, 6, to counts. How many times have I seen that combination? So I'm going to go through. Looks like, yeah, I did 1,000 times. I'll shuffle it and I'll figure out what is the combination number for that shuffling. So what combination did I end up with? And then I'm going to just go ahead and increment the count for that combination. It's about here where I realize that I probably should have initialized all of those counts to 0. Again, there's 2 different ways you could do this. You could do what I'm doing here, which is to go through all the possible combination numbers and set them equal to 0. Or you could do a find or create inside your for loop. Check and see if combination number is there, and if it is, increment it, and if it's not, set it equal to 1. It just, pick one. Both of those are fine. It's very easy to let yourself go crazy. Well, OmniSharp got stuck here, so I had to restart it. But it's very easy to let yourself go crazy trying to pick all of the different ways that you can do something. And I admit it's somewhat easy for me to say, oh, just pick one, when there are decisions that you make as you're writing an application that do have some significance, and there are decisions that you make as you're writing your application that don't have any significance. But in general, avoid premature optimization and just, try as best you can to keep writing code and fix things when they don't work. But, you have to somehow manage to just keep moving forward. It's so easy to get stuck and frustrated and lost in analysis paralysis. All right, so I'm getting here to, okay, how do I actually now assert that these are all roughly the same? So what I'm doing is I'm finding the smallest count and the largest count and checking the difference between them. I just picked 30. There is a actual statistics way you can figure out what that should be. You can find out whether the count should be no larger than blah with a p-value of 0.05. I'm not a master of statistics, and I didn't necessarily want to look it up. 30 sounded like a good idea at the time. So let's go ahead and run our test here. And it turns out that 30 was not the best idea because it ended up being 41. Is that good or is that bad? At this point, I actually had a bit of a crisis where I didn't know. Um, I did bump it up to 50, and obviously that's going to pass, but 41 seemed large to me with 1,000. So I really got to thinking, and I did end up actually looking into what statistics you would use. It's a chi-square test. And in order to do it, I had to see, okay, what is the value I get for each of the counts? And so what I'm doing here is I was throwing all the values into a list so I could very easily look at them in the debugger. Turns out you can actually very easily look at that map in the debugger too, so that was not necessarily needed, but I thought it was. So jump in here. All right, combination 1, 162, 168, 169, 164. So far, so good. And then it gets strange, 148 and 189. This seems wrong to me that four of these numbers would be so close together and then two of them would not be in that same general grouping. I did run this through the chi-square test and it agreed this is not a uniform distribution. And now is the part where I can tell you that I don't know everything. I studied my implementation of this quite a bit and I couldn't figure it out. I still think I've got the right implementation. I don't know what's going on here. One guess might be that the underlying random number generator is not perfectly uniform either. It seems odd to me that it would fail in this way. Um, so I don't know. It's interesting. I do want to look into it more, but in the making of this video, I didn't have enough time to look into it. So I ended up just accepting that difference of 50 and deciding it was good enough after some extensive study. Maybe in the next lesson, I'll be able to explain what went wrong there, or if someone wants to go figure this out, by all means, please do. But I do want to talk about this test now. Before, we were talking about whether it's a good test or a bad test. Again, this is fast, and it's always going to pass. Um, I've got that fixed seed. This is going to pass reliably. But now, if I went in and I changed the random number generator with a cryptographically secure random number generator, it would still pass. It wouldn't really matter. Um, Even if I didn't fix the seed of that cryptographically secure random number generator, I'd expect this to pass 95% of the time, which is not great, but I would live with that in that case. And also, if I ran into some edge case that was wrong and I had to change that loop in some way so that it generated more random numbers or generated random numbers in a different order, my test would still pass because what I'm testing now here is really something that's more meaningful. This is a much better test. It's asserting that a shuffler is actually shuffling uniformly, which is what it was supposed to do. It's what it was written to do. So I'm much happier with that test I ended up. Anyway, I'm out of time, and that actually completes our domain. This very simple vertical slice, that's really all we needed. Playing cards and some way to shuffle them. So I appreciate you for taking the time to watch this, and I hope to continue this next week. Oh, I lied. I did actually, for fun, check one other thing, which is if I go and I purposely implement this incorrectly, does my test break? So I changed that, one of the things that I was doing in there. And this is one of the things with writing a shuffling algorithm that can be very deceptive, is a shuffling algorithm can often get you what looks like a shuffled list, but it turns out not to be uniform. So I made a small change in there, and what happened was a number of, what basically the change I made was I said you can't swap with yourself. And so what happens is in certain sets of combinations are now no longer possible. And so they have 0 in their count, and you get a giant difference between the smallest of 0 and 342, which was one of the remaining ones. So the test did fail if I implemented the thing incorrectly. Again, all just evidence that I am much happier with this test. Okay, now for real, I will see you next week.